SNMP stands for Simple Network Management Protocol. The simple, this is also the protocol that mail servers use to exchange data is called Simple Mail Transfer Protocol. Well, but there's nothing simple. The main idea of SNMP is that you have devices that are monitored, and there is an observing station that just monitors the state of the device. Now, this monitoring is done with a protocol called the SNMP protocol, and the SNMP protocol is essentially a client-server protocol. The client-server protocol, where the manager, this is the monitor. The monitor is the client which asks any one of these computers devices that need to be monitored. These are then reserved. Now, a device can be pretty much any router, any host can be monitored. A printer. And if you're buying a decent printer that has a network connection, these printers can be monitored by SNMP. And you can ask, query how many pages does it have, what's the status of the color, these kind of things. Yeah, they can be queried with SNMP. For a router, the question that one can ask is, what is your configuration, what is your IP address, how many packets have you forwarded on each of your interfaces, how many errors have occurred, and so forth. So in the SNMP agent, the monitoring part is called the SNMP manager, and the server part, the part that is being monitored, that is called the agent, the SNMP agent. So manager and agent. The manager queries the agent. So that's something. Now, the information that the SNMP manager asks from the agent has a certain structure. That structure is the data in which it's structured uses a syntax, and the data that can be queried is described in a syntax on a file which is known to both the agent as well as the manager. The description of the statistic information, that's essentially statistic information that is being pulled, is described in what is called a MIP, management information base. There's a MIP for a router, there's a MIP for a printer, there's a MIP for an Ethernet switch, there are MIPs for everything. Vendors, equipment builders can add their device-specific information to a MIP. So these are then the components of SNMP. There is the manager part, the agent part, then the description of what data can be queried, that's the MIP, and then the SNMP protocol itself, which is the information between the queries that the manager sends and the structure of the responses. There's also something where the agents can be set so that they report when certain conditions hold. And for a router, an event would be link down. If the link fails, the monitoring station wants to be informed. In this case, there's no query taking place, and the agent by itself informs the manager about the state. That is called a trap. It's configured. So the manager configures a trap on the agent, meaning that once this condition holds, the agent gets into the trap and writes a title report. Now, this is an information that is used for. I should actually. Okay, give me 1 second. I can give you some feeling for the for information that can be queried. I just want to yeah, the internet. Let's see how it works. SMRTG graph. Toronto. MRTG in Google. MRTG graph. MRTG. Okay, GTA monitored links. Okay, so this is now information, which is, this should be live. No, it's not. This things were last updated September 25th, 2008. So let's maybe see if that's something. Maybe they're not running yet. University of Toronto. This has been disabled. I'm first time I see this here. Let's just see this. So this could be live data, should be live data. So this is data from a router. It has, so this is here, the IP address. It pretty much reports on the state of the link. So this is how data is being presented and what network administrators look at. A graph like this uses data over a 24-hour period, and it tells you how much of the data is used. Like here you see that the bits per second. You see here this bit in the morning hours, and during the daytime, you see that the data picks up on this particular link. The gigabit link is then loaded at 280 megabits per second. Also can be report you on and this can then be further be broken up. You can see here, you see the daily pattern, what is this here? The weekly pattern of the data. Now the daily pattern drops off at night, picks up during the day, over the weekend, much lower network activity. And so you see that here, input, output, you can average it. This is how data is presented. Yeah, over a monthly pattern. This is data. This is data collected with SNMP. So this program here sends and pretty much all devices on the network provide interfaces to monitor this. All right, so pretty much talked about this. So the terminology: SNMP agent, SNMP manager, MIP, database described, and the SNMP protocol, an application layer protocol running over UDP to send and exchange data between agents and so this is how it looks like in a protocol perspective. IP, UDP, SNMP. SNMP application layer protocol, HTTP, and it's running on top of UDP. And then the manager and the agent are essentially programs, application programs, which use the SNMP protocol to issue queries, receive replies, and receive traps. You see here, then the query results in an access of an object. The result of the query is a reply, which is data, which comes back here to the SNMP. That's the basic interaction, and the agent here uses the data is based on a MIP, which is the management information database. So a MIP specifies what can be managed, and these are files that are written in a syntax called ESN.1. It's a really very bloated syntax of describing a data format. I can give you an example here. So this one here is the description of a variable. This is the IP forward datagram. It's the number of IP datagrams that a router forwards. It's part of the MIP of a router. Now, the database of a router has this variable, IP forward datagram, which is the syntax tag. It's a counter that counts the number of packets that are forwarded. It's a read-only access status mandatory must be described, and then here it has the the number of info datagrams for which this entity was not their final IP destination. It's datagram that were received and are forwarded again. So this is the description. Down here is a number, IP6. So every data item that can be queried is called a managed object. So the information, number of datagram forward, is a managed object. Each object has an identifier. It's called the object identifier. Object identifiers look like this: 1.3, 0.6, 0.1, 0.2, 0.1, 0.4, 0.6. That is the number, the query that is sent when a monitor, a manager, SNMP manager, wants to ask a router how many IP datagram it has transmitted. It sends this number in a query. And this number is structured in a way that it can be interpreted. It's part of a hierarchical structure, and the structure is from top down: ISO, org, DoD, Internet Management, MIP2, IP, IP4 datagram. And it's part of a global tree of managed objects. So this one here, think at the root, is the root, is the universe of all data that can be queried. Then ISO stands for Internet Standard Order. We really don't have to worry about anything that is queried that has to do with the Internet goes down ISO, org, DoD, Internet. And everything that's managed is management. Yeah? MIP2 is a kind of a second version of a structure of the management information base. This is MIP2's second generation of a MIP structure. So this is MIP2. Then you're asking here, so this one, if you're dealing with anything that uses a management information base of type 2, starts out with 1.3, 0.6, 0.1, 0.3, 0.1. Then you're going IP. .IP means you're asking something that relates to the IP protocol. .6 would be TCP. .7 UDP. .2, you're asking something about the network interface. So you're asking essentially information about the driver. And here among IP, there is the IP4 datagram. This is number 6, and this is now how you read this from the MIP. If it's written in the MIP like this, IP6 means, it has the object identifier is everything, the object identifier of IP, and then 6 additive, which then results in this number. So the this IP4 datagram is in fact this number that I showed. And so the SNMP manager sends the number, and then it gets the number back with the value written in. So there are predefined MIPs, but it's also that manufacturers can add product-specific information, and it's often also the case that product managers, product manufacturers, they have non-published portions of the MIP, which they then use for proprietary monitoring tools or proprietary debugging and whatever features. Yeah? Okay. So that's this. All right. The basic interaction of SNMP is the agent is sitting at port 61. The SNMP manager can be any port number, with the difference is that traps get reported to port number 162. And because you have to be well-known port for SNMP agent is port 61, and so the issue is that the interaction is the query is sent in a GET request, and then the reply from the agent is a GET response. And then there's this command called GET next request. GET next request. That means that it's one obtains the question for the next item, the next managed object, in order. So by sending a sequence of these requests, one can get information about the entire MIP. And because of this GET next request, asking for multiple items is called walking the MIP. When you walk the MIP, you're essentially asking for all items. This GET next request is part of SNMP version 1. There's SNMP version 2, where you can ask for larger chunks. Yeah, so today one can ask for larger chunks. Set request and set response. This should be set response. Sorry, set request and set response. This is used when the agent changes the configuration. And one can actually change the IP address. It is possible to change the IP address of a router using SNMP. And the IP address is a writable object identifier. Of course, if you're doing something wrong, you're changing the IP address on the port that you're configuring, you better know what you're doing. That's not the best way to do it, yeah, but other configuration information can be written. However, usually it's just about reading data. One wants to know the status of the data. So the basic interaction is manager sends queries, agent replies, with the exception of a trap. Yeah, a trap is just something that is initiated by the agent without any prior query by the manager. And that has to be configured. A trap has to be configured. And that's something that you would do in the lab. In lab number 9, you're configuring a trap, and then you're configuring a trap for a link down, and then you're disconnecting a link, and then the trap is triggered. Yeah, what else is there to say? We've pretty much covered. Now, trap is a notification sent by SNMP into SNMP, which is triggered by certain events of the user. So examples of traps include link down. That's probably the most important one. If the interface goes down, yeah, cable is reformed. A reboot gets reported. Yeah. A system crash gets reported. Of course, you have to boot up. Yeah, if the system went down without having properly been shut down. Yeah, so that's link up, the opposite of link down. Yes.
If the link goes down, how do you send the information to the manager?
Well, you don't get there's a link down. Yeah, the link that is down, that's the down link. That doesn't report anything.
So there's not actually something sent from
Like how can you get the report that the
yeah.
that the messenger is dead? You know, or somebody else reported it. Yeah. Same thing here. Logic applies. The same with a system with a system crash. How do you report a system crash? Well, as long as the system is down, nothing is reported. So here it's about different interfaces. All right, versions of SNMP. So there are a total of 3 versions of SNMP. There is actually some history to this. SNMP version 1, very old, you see 1990. A terrible security. There's a clear password that is written. It's called the community string. It's a clear password written in each packet. And when you're querying, you're setting IP addresses. Then people tried to build SNMP a new version, and there were a couple of things with the protocol. Like this one limitation was this get next. So there was this get bar. You can ask for an entire subtree. That's great. That's all. There's also this RMON entity. So it's something to build to allow remote monitoring. It's just something that builds some infrastructure to have simpler remote monitoring there. But it also tried to tackle security, to have a better security interface, and that failed. They didn't get off the ground. There was a disagreement. There were several different proposals and that were being discussed. This all happened in the IETF. They did not converge. So what they converged to was these new features of SNMP, but without the security. So the version that is being standardized then as version 2 is SNMP version 2C, where C stands for community, which is pretty much using the old clear text secure password using the old clear text password with community string, but having additional features. Now, since 2002, which is now a long time, there is a lot of security added to SNMP version 3. The right way to do it would be kind of pretty not so interesting to talk about, but if you configure it in lab number 9, you would configure it and then see and snoop the traffic and really see that it's quite tight security. The issue, however, is for the tighter security features of SNMP version 3, one needs to have a lot of configuration at the agent. Like if you're using passwords, then the passwords have to, of course, be configured. Yeah? So usually all versions are still being used. There's a lot of SNMP version 1 and 2C still around. And that version 3 is the one that kind of pretty much closes the loophole. As for the structures, not so interesting. So this is an SNMP version 1 packet. You see there's the version, there's the community string, that's the password, yeah? So that's the clear text string. And it's ridiculous. I mean, I don't even know what to say. Not only do you send it clear text, it's also sent in each query. Yeah. That was a different time, obviously, yeah? But this is something interesting. Yeah, you see these things, you don't believe it. Yeah? If you would do this in your sophomore programming class, you would get a failing grade. Yet the infrastructure is running on it. It's really, the internet is really based on very simple protocols. designed decades ago. Yeah, and what we're doing right now is really dealing with the shortcomings of it as it's now used to handle the infrastructure. SNMP was not there to be built, was built as a research network. There's nobody doing anything bad on a research network where everybody is being paid by the same agency. It's like an enterprise network. So that's the context of it. It's not that people were stupid, it was just not an issue. Alright, so different types, requests. Yeah, and then one can give, this is the object value. Object value is the object identifier within the value. Yeah, so there can be several of those, can be sent in a single query. So about security, plain text with community strings. Yeah, so SNMP version 2, its primary mission was to add security to SNMP, but didn't do it. So the C standard, the community string. So now SNMP version 3 has many features, perhaps integrity, authentication, and privacy. Yeah? Authentication means, integrity means essentially non-repudiation. There's a digital hash on queries and replies, so that if somebody sends a reply, the receiver can verify that it has been sent by that route. Then essentially public-private key type of encryption. Then authentication is also done, can also be done with a digital signature, and then privacy then encrypts then the payload, so it cannot be read. And that's pretty much, yeah. This part here, yeah, there is more to the. There is more to SNMP version 3 in the configuration. But, this doesn't. It's too practical. Unless you run the labs, we don't need to go into this. There are modules there and additions to the MIT. The big part that we're dealing there with is this VACN there, this version-based access control module. And then one can set the access rights here. So the idea is then that we can say these and these IP addresses are queries, and one can say this IP address, if we get a request for this IP address, they can query only a certain part of the SNMP tree. And that's pretty much it, I guess. Yeah. So just wanted to give you a brief introduction about SNMP, network management. So tomorrow we discuss the quiz number 2.